Hey guys, welcome to Coding Encrypt. My name is Sylvester, and today we will be doing loops, looping constructs, and nested loops. So before we actually talk about decoding, we need to know what exactly is a loop. A loop is a sequence of instruction that is continually repeated until a certain condition is reached. And that is the definition. So in simple terms, a loop is a group of statements or instructions which are repeated until we achieve a certain point. So a common real life example would be when trying to unlock your phone. Your The phone software allows you to attempt 5 times before it locks itself. So it keeps track of the number of attempts, and you can enter it once, twice, 3 times, 4 times, 5 times wrong. But on the fifth attempt, if you fail, it locks you out. So we have this flow chart over here, which over here we have the initialization expression. So the initialization expression is what begins the loop. So whether it be like initializing a bunch of variables, or here the initialization expression would be switching on your locked phone. So that would be our initialization expression. Then we have a test condition. It tests whether you have failed 5 times. If not, well then you can have another attempt. And each time an attempt is made, it updates the number of attempts. So if it's 0, if you fail once, it adds 1, then 2, 3, 4, and on the fifth time, it will notice that you have failed 5 times and it will exit the loop and lock you out. So in Java, we have 3 types of loops. We have the for loop, the while loop, and the do while loop. Now the while loop and the do while loop are quite similar. However, the for loop is a little different, but more easier to understand. So we'll begin with the for loop. In the for loop, we have parentheses, which has the initialization, the condition, and the update statement. And of course, we have the loop body, which is contained within curly brackets. Just remember that. So the initialization is basically whatever is created at the beginning of the loop when you first enter it, and this does not change after the loop is repeated again and again. It remains constant. However, if a variable is initialized within the loop, then it can change afterwards, but the statement is itself doesn't change. Next, we have the condition. So a condition would be something which actually gives value to the loop. If there's no condition statement, these loops are worthless, as they might go on forever or just end abruptly, which is why we need a condition statement. So a conditional statement would be, for example, a variable x less than 5. So as long as it's less than 5, it will constantly repeat. And finally, our update statement over here. The update statement is something that allows the loop to keep track of how many times it's been run. So generally, at the end of each loop, we have the loop updates so that it keeps track of how many times you have run the loop. So if it's run once, it updates once. If it's run twice, it's updated again. So it's a way to nicely keep track of everything that goes on within the loop. In a while loop, things are a little different. We have our initialization outside of the loop. In a while loop, the initialization and the update statement are optional. It's also true for the do while loop and also for the for loop, but we'll get to that later. So we have a condition, which is once again I'd like to repeat that it's compulsory to have a condition, and the while loop will repeat as many times as it wants until the condition is no longer true. So just remember, it will repeat as long as the condition is true. If it's false, then it exits the loop. And for the do while loop, things are a little different. Here, even if the condition is false, it runs the statements within the loop body at least once. If it's false, it exits after the first run. Otherwise, it loops again and again until the condition is no longer met. Alright, so now we have entry and exit control loops. Entry control loops, what exactly are they? Well, entry control loops are those, as the name suggests, the loops that controls the entry into the loop. So it's basically, in technical terms, the loops in which the test expression is checked before entering the loop. And one thing that is quite peculiar about this is that if the conditional statement is false on the first time, it is once you enter an entry control loop, it is never executed. So you could completely skip an entire loop because it's an entry control loop. And for loop and while loop are two prime examples. In fact, they are the only examples in Java. Next, we have the exit control loops, which are the opposite of entry control loops, where the test expression is checked after the loop body is executed once. So this allows the loop to always be executed at least one time. And if this conditional statement is true after that, well, then it will repeat until, of course, it's no longer true. And the do while loop, as we saw previously, always has the first attempt, the first time when this, and the do while loop always allows the loop body to be executed once before exiting, at least once. Alright, so before we go into nested loops, I'll just show you on BlueJ, which is an IDE for Java, the different kinds of loops. So as you can see over here, we have three different methods. So each of these yellow boxes, they're known as methods. So we have public static void for loop, while loop, and do while loop. Now over here, just remember that this is just a name which is used to identify which kind of loop, which kind of method it is. So in our for loop method, we have s and I being initialized outside. Now, as I said before, that the initialization, the condition, and the update statement are all in one single parentheses. However, this is not necessary. You can have the initialization statements outside of the for loop, but always before. Otherwise, it's not an initialization statement for the loop. And the update statement, instead of it being in here, you can have it outside. So we can have it right over here, and nothing would change. So one thing about this is, if you keep the update statement within the parentheses, then it is always run. However, you can limit when this is run using an if statement. So if I is less than 3, then we run this. But of course, if we were to do this, the loop would run on forever. So let's just remove this. So this particular function or method, they're both the same thing. If I say function or method, they mean the same. So this function takes the sum from 1 to 5. Over here it's 0, but if you add 0 to 0, well, then you get 0, so it doesn't matter. So it adds 1 to s, as over here. This is a shorthand shorthand operator which equates to this s equals to s plus 1. So we take s equals to 0 plus 1, then you add 2, 3, 4, 5, and at the end of that it exits the loop and prints whatever is in s. And we know that it's the sum from 1 to 5, so if we were to run this, we get the sum from 1 to 5 equals 15, which is completely true. Alright, next we have the while loop, and over here we have the initialization statement outside. Just remember, initialization statement outside and before, and the update statement inside of the loop. So we have a conditional statement within the parentheses, and as long as x less than 64, it'll run on forever. Now one thing you might not have known is that you can have equations within a print statement or within any parentheses. It doesn't matter. So over here we take the number x, whether it be 1 or some value in the future while the loop runs, and multiply that by 2. So it's the equivalent of taking the powers of 2. So we get 2, 4, 8, 16 and so on, until of course this is not achieved, this condition is no longer true. So if we were to run this, well, we get 2, 4, 8, 16, 32 and 64. Now the final do while loop, we must remember that it's always run at least once. Even if it's false, as we put here, y equals 0, well, we know that y shouldn't be equal to 0, but if we were to run this, well, it goes on forever. But we don't want that, so let's just stop that right there before anything goes wrong. And we'll put this back to 10. So as long as y is not equal to 0, this will run, but this always runs the loop body at least once. And depending on whether or not the condition is true, it will either repeat or exit the loop. So if we were to run this now, I'll just give you a few moments to figure out what exactly will be printed. Alright. So if you guess that it's from the numbers from 9 to 0, well then you're correct. Alright, so returning back to our slideshow, we have nested loops, which is basically a loop nested within a loop. That's why it's called a nested loop. So how exactly does this nested loop actually work? Because we have a loop outside and a loop inside, do you think both loops would loop at the same time? Or would one precede the other? Well, when a nested loop is reached, the outer loop is first executed for the first time. So the outer loop, as we can see over here, the one with the variable I, is executed for the first time. And once this happens, the inner loop is executed n times. So how many ever times it goes, repeats, depending on the conditional statement and the initialization and the update statement, it will run that many times. And only once the inner loop is exited, will the outer loop continue. And once the outer loop is completed, it repeats the second time, the third time or fourth time, however long it will go on. But just remember that once the outer loop is executed and the inner loop is reached, the inner loop must complete first, and then only it will exit the inner loop and continue on with the outer loop statements. So if you were to give the dry run, which is basically like a written way of showing what exactly happens in the background of the computer. So we have I starts off as 0 and j starts off as 0, as we can see over here. So then it prints I and j with a space in between, so we get 0, 0. Now we must remember I remains 0, but j changes. Just remember that the inner loop only changes, not the outer loop. So I remains 0 and j now is 1, then we get 0 1. Then j is added, we get 2. But is 2 less than 2? No, that's false, so it exits the inner loop. And then we get I is equal to 1 after we print to the next line. So we do this until the entire thing is over, and we get 0 0 0 1, 1 0 1 1, 2 0 2 1, all of these in different lines. So why exactly do we need a nested loop? Well, if there is a case where we need to repeat something again and again inside of a loop, meaning for each iteration within that loop we want to repeat something, well then it would obviously make sense to put a loop within the loop, right? Exactly. So that would be the most simple reason as to why we would want to use a nested loop. So let me just open BlueJ again. Alright, and open this class called primes. Over here we have a scanner class, and we accept a limit, which is a number, from the user. Over here we want to go from the number 1 all the way to the limit, as in we go from 1 2 3 4. If the limit is 5, we go 1 2 3 4 5, and we want to see whether that number is a prime. Of course, if the number is prime, then we print it as over here. And what this inner loop does is that it iterates from 2 to I, and it checks whether there is any factor, meaning if the remainder when I is divided by j is equal to 0, that would be this expression said in English, then it isn't prime. If it isn't prime, we don't print it. Let's assume we take a random number 3. Well, we first check the number 2. Why do we not check 1? Of course, because 1 is the factor of every single number. So we check if 3 mod 1, as in does 3 divided by 2, does it have a remainder? If no, then it isn't a prime. But 3 divided by 2, of course it does. 2 does not divide 3 perfectly. We move on to 3, but 3 is the number itself. So if the numbers are equal, then we just exit this inner loop. And since is prime, which is a Boolean variable, it never turned false. That means it is a prime, and we print it. So let's just run this code and see what happens. Okay, if I put the number 7, we get 1, 2, 3, 5, and 7. Of course, there's a problem here because 1 is not a prime. So what I can do is just update this, and there we go. If I was to run this again, I put maybe a larger number like 80. There we go. We got every single prime from, of course, 1 all the way till 80. 2, 3, 5, 7, 11, 13, 17, 19, and so on. Those are all primes. So this code works perfectly. Okay, so let's try another example. So I'm just going to create a class called pattern. And we want to create a pattern, as you can see. So we want to create that pattern. So let me just clear out this clutter. Create our default method called public static void main. Okay, so first of all, we're going to need multiple loops to create this. So we need an outer loop, of course, and the outer loop will, of course, tell us how many rows we want. Rows, as in, the horizontal rows. So clearly we want 4 rows over here. So let me just do I equals 1. I is less than equal to 4. We know that because of this condition, and if we were to iterate one at a time, this loop would iterate 4 times. Now, of course, to get this particular thing, we need to use another loop. And this loop will print out the different spaces before we get on to the first triangle. So we of course create for in J, and as you can see, of course, the number of spaces that are present are equal to the number, which is the number of rows minus I, right? So of course, if we had the first row would have 3 spaces before. The second row would have 2 spaces, the third row would have 1 space, and the last row would have no space, which is why we take 4 minus I. Then we make sure that J is always greater than or equal to 1, and then we decrement, meaning we subtract 1 each time from J. And here we do system.out.print, and we print out a single space. Just remember, do not use print line, because what print line does is go to the next line. We want to do that all the way at the end. Now we want to print out the number of hashtags. So we'll have another loop. CS is getting a little tiresome, but bear with me. 1 and K is less than equal to I. Sorry. And why less than equal to? Because each time it's increasing by 1. So in the first row we have 1. In the second row we have 1 plus 1, which is 2. In the third row we have, and so on. So now we print system.out.print, and we print out a hashtag. Next, we of course want to print a single space in between. So we do system.out.print. We put a single space. Now a final one, which will be again the number of rows. So it will be this exact same loop repeated. To avoid confusion, I'm just gonna replace K with L. And theoretically, this should work perfectly. Of course, there was one single problem which I missed out on, which is of course to move on to the next line. And this should work perfectly. As you can see, we got the exact same pattern as in the image. There are no spaces here. We have first 3, 2, 1. And of course, we don't need to print spaces after this hashtag over here, or this hashtag, or this, because the user will not be able to see the spaces anyways. So it doesn't matter. And that's all that we have to do. So now let's move on back to the PPT. Now one thing I'd like to give you are 3 more patterns. I'd like you to try these 3 patterns at home or whenever you're available, so that you can actually learn and remember everything we've learned over here. So just a quick recap. Loops are a collection of statements which are repeated until a certain condition is met. And we have 3 types of loops in Java. We have the for loop, the while loop, and of course the do while loop. Now we must remember that the conditional statement is absolutely necessary in loops, while the initialization statement and the update statement are optional. And finally, nested loops are loops within a loop, and it always completes the inner loop before returning back to the outer loop. So that's all we have. Thank you for watching Coding Encrypt. My name is Sylvester. Goodbye.